During the second half of the 20th century, the demand for meat has significantly increased, putting pressure on the production of cattle breeds. Usually, animals are shipped abroad, but that has ethical implications in terms of live animal exports, animal welfare, etc., in addition to the contribution to climate change. An alternative to the shipping of live animals is the shipping of the embryos, and with the animals being reared in the destination countries. But embryo production requires careful assessment of embryo viability ahead of implantation, and the processes tend to be subjective, requiring trained IVF technicians and are time consuming. Additionally, certain cattle embryos are fairly opaque when compared to human IVF, making it difficult to carry out these assessments. Previously, some colleagues in our research group have investigated the viability and activity of bovine embryos using optical coherence tomography and angiography. This approach, however, presented some limitations, as it was an invasive imaging protocol with the embryos being disturbed during the imaging procedure, removed from their culture medium, and it was also a time resource intensive protocol because the imaging was done as a serial process with no possibility of automation or parallelization. Currently, we are developing an OCT imaging probe which can be introduced into an environmental chamber. This environmental chamber presents control over temperature, humidity, gas ratios, and the probe itself is a high-resolution imaging probe with a lateral resolution of 2 to 4 microns, with remote focus adjustment, imaging interface, dimension for specialist Petri imaging dishes. And these Petri imaging dishes are multi-well dishes that allow simultaneous assessment of up to 16 embryos placed in individual microwells. Additionally, a portable companion OCT interferometer was developed, which will be transferred to the IVF lab and used by IVF biologists in conjunction with the imaging probe. The OCT angiography protocol and master slave OCT will be used with the imaging, which will allow easy assessment and simplification of the workflow of IVF production. Porcine oocytes have been imaged as part of the preliminary data collection, allowing the identification of several morphological features such as the zona pellucida and the germinal vesicle. Future work involves the first trials in the environmental chamber and the ultimate integration of the system in the IVF lab workflow. Beyond the cattle IVF, we also intend to extend this procedure and this system to human IVF procedures.